In part A of this question, what we have done first is draw a free body diagram showing the two forces that are acting on this roof. Of course, we have the downward acting gravitational force, which we have labeled mg, and then the upward force that is actually lifting the roof upward by the 10 centimeters. Now, what's important to understand is that this roof is presumably being raised at a constant velocity. So this would mean that the acceleration of the roof would equal 0 meters per second squared. And since there is no acceleration, what that essentially means is that the magnitude of the upward force will be equal to the magnitude of the gravitational force. If that were not true, then there would be an acceleration. But of course there isn't. So what we're saying here is that the upward force F in magnitude is equal to the downward gravitational force mg in magnitude. We then turn to the expression for work, which is actually what we're trying to calculate here, and we can see that work is equal to the magnitude of the force times the magnitude of the displacement multiplied by the cosine of the angle. And it's important to note that that angle is between the directions of the force and the displacement. Now, for the work being done by this force, which is upward, we know that since the displacement is also upward, that the angle between those two would be 0 degrees. So we're going to come down here and use the work equation. And again, remember, for the force, we've determined that the magnitude of that force, F, is equivalent to mg. So we're going to fill in mg for that force. And then multiplied by the displacement. The displacement is given in centimeters, so you're going to have to take your displacement, and to convert it into meters, you multiply by 10 to the minus 2. So that would get it into meters, and then that's times the cosine of the 0 degree angle that we determined earlier. So we next note that mg, which is the gravitational force, sometimes called the weight of the object, that's actually given to us directly as 360 kilonewtons. So what we're going to actually do is take mg and substitute the 360 kilonewtons for that mg. Now remember, kilonewtons is non-standard, so you're going to have to take 360, and to get it into newtons, you multiply by 10 to the power of 3. So now we are ready to pick up our calculators. Make sure your calculator is set to degree mode. Alternatively, you may remember that cosine of 0 is 1, so actually we can kind of disregard this. And we punch this into our calculator, and we end up with 36,000. And then the unit could be expressed as either Newton meters or more succinctly as joules. So this would be the correct answer to part A of the question. In part B, we have a similar situation. This time we have a panicked individual exerting a 4,000 Newton force in lifting a car 5 centimeters. So the free body diagram for that situation is essentially the same. We have the downward mg force, and then we have the upward lifting force. They're equal in magnitude because there's no acceleration. It's the same argument as before. So we're going to have the work equals the mg force multiplied by the displacement magnitude, multiplied by the cosine of the angle between force and displacement. Again, the displacement is upward, so the angle between that displacement and that force is 0 degrees. So we plug in for mg, that was given as 4,000 newtons. She lifts the car by 5 centimeters, so we'll have 5 multiplied by 10 to the minus 2. That will, of course, get it into meters, times the cosine of 0 degrees. You can punch this one into your calculator as well. And when you do so, you should end up with a work of 200. And again, this will come out in joules. So this is the correct answer to part B.